Yeah, she come around in my coupe. Shawty might cut me loose. Shawty might work the truth. You know me, I don't play by rules. She always run around in my coupe. I know she's tired too. Really look that she gon' find a new dude, so I better stop wildin' up. She got her run around in my coupe. Shawty might cut me loose. Shawty might want the truth. You know me, I don't play by rules. But she always run around in my coupe. I know she's tired too. Pretty little thing, she gon' find a new dude, so I better stop wildin' up. Okay, first things first, like I gotta take the red light. I could tell it was my shorty by the headlights. Told my side piece, look she ain't tryna lose her head. When I came home, I be bleeding by the bed like, baby, it ain't what it looks like, you was tripping. I ain't even see you look right, how you figure? I was lying on my dick so I could save me. When she told me you can't pay me. And here she comes, riding around in my car with someone else. And I can't blame her 'cause I blame myself. And I just pray that she don't give up. She got her run in my coupe. Shawty might cut me loose. Shawty might work the truth. You know me, I don't play by rules. She always run around in my coupe. I know she's sorry too. Pretty little thing, she gon' find a new dude, so I better stop wildin' out. She got her run in my coupe. Shawty might cut me loose. Shawty might want the truth. You know me, I don't play by rules. But she always run around in my coupe. I know she's sorry too. Pretty little thing, she gon' find a new dude, so I better stop wildin' out. And I hate it 'cause I wanna be a player, but my relationship gon' be the one to take the time. So I say wildin'. You, I'm silent. But here she comes, riding around in my car with someone else. And I can't blame her 'cause I play myself. I think I gotta find me someone else. She caught her run in my coupe. Shawty might cut me loose. Shawty might work the truth. You know me, I don't play by rules. She was running in my coupe. I know she saw it too. Pretty little thing, she gon' find a new dude, so I better stop wildin' out. She caught her run in my coupe. Shawty might cut me loose. Shawty might want the truth, but you know me, I don't play by rules. But she was running around in my coupe. I know she saw it too. Pretty little thing, she gon' find a new dude, so I better stop wildin' out. There's no time, get this creeping by my side. Lost in haze and sleep deprived, losing pieces of my mind. Stuck, I can't turn back time. Yeah, it feels like better days. Now I sit and waste away. Watch my lips slowly decay. Bury me and give me all the extracts. I'ma smoke a pound of it. Need a box of rap, staring to the burning blaze. Gray clouds only fill my days. All I feel is rage. No escaping from this maze. Cannot wait to beat the grave. Hope this is my saving grace. Hope I can just rest in peace. Throw my body in the flames. Some days I feel so insane. Never miss up in my lane. Acid test with my membrane. Man, I still don't feel the same. Yeah, so all my movements are look for improvement stuff. And when I've been going through it, I'm about to go lose it. I'm about to go get it, get run to the hills, they completed the mission. Something missing about my addiction. I love the addiction, and you know I feel it. Consider my feelings, I don't give up. Yes, I don't broken, I have given up. Never had my wrist up, looking at change. When I'm on the left, it's steady rolling up. Getting literally speaking the truth, and I won't get it touched. Got a new motor, my blood was a difference. I said it and proved it. Your break feeling still with my life feeling golden. It's like I was doing my heart is still frozen so deep in the ocean.
Waste no time, get this creeping by my side. Lost in haze and sleep deprived, losing pieces of my mind. Stuck, I cannot turn back time. Yeah, it feels like better days. Now I sit and waste away. Watch my lips slowly decay.
Waste no time, get this creeping by my side. Lost in haze and sleep deprived, losing pieces of my mind. Stuck, I cannot turn back time. Yeah, it feels like better days. Now I sit and waste away. Watch my lips slowly decay. Waste no time, get this creeping by my side. Lost in haze and sleep deprived, losing pieces of my mind. Stuck, I cannot turn back time. Yeah, it feels like better days. Now I sit and waste away. Watch my lips slowly decay. Okay, I think we are about to start. Yes, it's 6:30, so it's the highest time for us to start the first ever Cloud Online Meetup. Hi, guys, welcome to our online meetup. I'm really glad to see you guys. 127 people right now are joining us. More and more people are joining the stream. If you want to, please say hello in a chat in the comments down below. Please say hello. Hi, guys. Tell me if you can see me and if you can hear me right now. Our speaker today will join us in a few short moments, but I would like for you to join us as fast as you can. Okay, more and more people are coming, so I won't be making it any longer. Guys, welcome, as I said, to the first Cloud Online Meetup, an event that is dedicated to cloud computing specialists. And as this is our first event, right away, I think this is not our last event. We encourage you to join us on our social media outlets. As you can see, we are available for you on YouTube and Facebook. So please be sure to subscribe our channel on YouTube and also give us a like on Facebook. And that way you will be updated on the upcoming events and our speakers. About our aim, we want to integrate specialists in Azure, in AWS, and Google Cloud Platform. So we are really happy that more and more specialists are joining us right now. Yo, says Daniel. Hi. Hi, hello. Hello, great to see you guys. Everything's fine. We can hear you. We can see you. It's okay, says Pavel. Yeah, Pavel, who is our Cloud Online Meetup leader. So I'm really pleased to welcome you guys all on behalf of Pavel, who is taking care of everything that is technical today. And this is our main sponsor. Big shout out and a huge thanks to our main sponsor, which is Luxoft. Thank you so much for supporting the community and being here with us, making this event possible. Now, of course, we are here to integrate, we are here to meet inspiring people, but we are also here to gain some very, very valuable knowledge. And who else could give you some knowledge today? If not Yerlan Akjanov, who joins us today. He is a senior software developer at Luxoft. For several years, he's presented and defended IT solutions for C-level executives and board members of large corporations, and he's participated in developing the roadmaps of large-scale enterprise systems. He wrote the first line of code 25 years ago. Of the personal achievements, as he wrote in a short bio for us, he screwed up in front of the president and survived the storm. And these two events are in no way connected. I hope that Yerlan will tell you a bit more about those events because it sounds fascinating. Now, the topic of today's presentation is from on-premise monoliths to cloud-native microservices, the inter-paradigm mindset journey. The story of how a team that is specialized in the development of internal solutions deployed on closed infrastructures for many years
moved to the cloud, how the whole team's view of problems and solutions has changed, what happened in the end, and what remains to be done. If you guys have any questions during our speakers' presentations, please be sure to leave your questions in the chat box or in the comments section, depending on what stream you guys are joining us with. And we will try to ask all of them to our speaker, and he will answer them in a short Q&A session. Also, we are happy to say that we have a competition for you. You can win. Just the only thing you have to do is fill in a form, and you get a chance to win a Jabra Elite 65 active wireless earphones, and also you can win a power bank. And you can, I think you can already see, yes, you can see the link to the competition in the comments or in the chat box. So please be sure to check this also. And now, joining us is Yerlan Agzhanov. Hello, great to have you here. Hi.
Hi. Can you hear me?
Yeah, we can hear you really well. I think we can hear you even too well. Okay, right now it should be better. Hello, Yerlan. Great to have you here, and I'm leaving you with our viewers.
Okay, nice. Nice to be with you guys. Dear participants, I would like to start my presentation from the question: have you ever thought about what makes us a group, AV professionals in some specific areas? So the answer is, according to my opinion, that when we start our careers, we are just open to anything that helps us to deal with our problems that we are facing with in our day-to-day job. And over the time, we learn so much things that we become, that made us become a specialist in some area. And this means that we have just enough tools to deal with all of the problems in the field. And when new types of problems appear, we desperately try to apply all our approaches to them, sometimes even regardless of the effectiveness of them. So it means that we are sticking to the methods that we are using, and even without even understanding that whether they're effective or not. And we're trying to find, when we understand that our existing approaches doesn't help us a lot, we're trying to find new ways to solve the problems, and this particular process may end up questioning the existing ones. So this what's really happened in the example I would like to start with. On your screen, you can see this is the actual truck that was released by Toyota in the early years after the World War II, the thing called Model K, the Model K truck. As you can see, this truck not only have the most bodywork done using the woods, it also has only one headlight, which is noticeable, and a single braking system, which were attached only to one wheel. And this happened due to material shortage. Japan was experienced some shortages in the materials and were unable to fulfill the requirements in those materials for their own car manufacturers. So they ended up with these cars being released. This is a real car that reached the market. So can you think of how did they solve this problem? Because as we know right now, Toyota not only makes the most luxury car nowadays. These are just a couple of them which I randomly selected. You know all of them well. Any of you can select any car for any sensor. So this is not the idea is Toyota not just releases the good cars, but it also sits on the first place in the car market. According to the market share. So Toyota releases and sells more cars. In the price, even than the Volkswagen, which a car concern consists of a couple of brands cars. So as you know. So what was the solution that Toyota came with to overcome the material shortage? So this is the problem that actually is not easy to overcome because it's just lack of the resources. So they came up with these few ideas. The first is called JIT and Kaizen. Actually, there are much more things being done back then, and most of these methodologies that they developed then, especially in management, we are all familiar with today. For example, this particular transition of the company became a popular subject of study in the 90s, when so many research papers has been published over the Toyota success case. And just to let you know, for example, Kanban, the thing that we're using today a lot, was developed as a part of one of these concepts, and I will point it out which one. So what are all these things about? The first one, JIT, stands for just in time. So the idea is that beforehand, this approach has completely changed the way the supply chain worked, because this was particularly focused on how supply chain worked back then. So before this concept idea was developed, all companies, and especially manufacturers, those who are working within the production lines, non-stopping production lines, were thinking that the more components you have shelved on your stocks, then less logistics-related risk you will be dealing with during the production. Because if you haven't managed some particular part being delivered at the moment it is required, it makes the whole production line to stop, which in turn causes significant monetary losses. And the new approach tends to exact opposite, to minimize the stock amounts and instead focus on predicting demand upfront with a higher level of precision. By the way, the main purpose of the Kanban that I mentioned earlier was to make those predictions more accurate. So the idea is to visualize each entity, what is the stage for each entity to be produced. So this is what initially Kanban was designed for. And in addition, working with mitigating the risk, because even if those risks are inevitable, they still can be manageable. And if you have a proper framework, of course, to manage those risks, which they did, which they mainly developed. And on the other hand, this particular intent led to another framework, which is Kaizen. Kaizen stands for continuous improvement. This framework is focusing on the ways that to optimize the processes. So the retrospective, for example, the one thing that we do in our day-to-day job nowadays, is the one of how Kaizen may be implemented in the project or in the company. So the general idea is to apply the procedures on each level, forcing the teams to analyze everything they have done so far for ways to improve the efficiency. So the focus of Kaizen is to improve the efficiency. And this is applicable not only to production line, but even on the highest, on the C-level management and all levels. So Kaizen is the idea to focus on improvement constantly. So these two concepts made significant changes in Japan's car manufacturing. I mean, apart from overcoming the material shortage, which they just dealt with, handled by the reordering, the reprioritizing the things that they need to purchase. They analyze the whole supply chain, all things that may go wrong, and all the risk has been calculated, and having on hand just the date when each particular part needs to be delivered on the production line, they can analyze which exact date this particular part needs to be ordered on. So these changes that car manufacturer has deployed to its business many years ago they reflected even in the way modern clinics, hospitals to operate. For example, some Canadian hospitals are utilizing these approaches in order to increase the performance, increase the effectiveness of their processes. So this is a good idea. But the key thought I was trying to spot is not that they just invented the Kanban and we're good with that. So my idea is the fact that sometimes we need to completely rebuild the way we solve our problems, just start from the scratch to overcome the limitations of our own experience, which sometimes plays against us. And today we will not be talking about the Kanban, but rather I would like to share with you a story of a team that I've been a part of a couple of years ago. So the story will describe what are the challenges we as a team have faced with during the transition, what are the decisions we've made and why we did that, and what we regret the most, and what we've done differently, have had another opportunity to do this. I hope this will help some of you to start your journey to trigger your journey, or maybe you've already done this and just will reanalyze what you've done. Maybe you will have done something differently. Yeah, so talking about myself, my name is Yerlan Angjanov. As being said, I'm a senior software developer at Luxoft at the moment. I mean, the first line of code I've written, yeah, it's exactly 23 years ago. This was done on the computer, which looks exactly like this one. Of the most interesting facts about myself is that I really indeed failed in front of the president, and I like to think that for some period of time I've been in the blacklist of the president of the country. I survived a storm on catamaran. I've been a storm and I survived it, and I also suffered fire. So there's been a couple of major challenges that I've been through. But today we'll be talking about the different things. So let's move on. Today's presentation will be split into 3 parts. And welcome to the first one, the old approach. Just before we will dive into the story, let me describe the project that we've done before. I mean, we as a team that being done before. What is our experience? So I will let you, maybe it will let you understand the level of problems that we have successful at. We have been. Our portfolio is represented by the, for example, as an example, document flow automation systems. So these systems that automate the process of interchanging the electronically scanned papers between multiple different organizations in a highly regulated area. Another type is the electronic archive system. So it covers not only the storing the tons of files, but also it automates the process around that. So like providing temporary accesses or approving the requests or moving those, I mean, storing, shelving, and so on and so on. So there are plenty of the processes that is covered by our systems. And next are the call centers. We've successfully deployed multiple projects to automate the call processes. I mean, the one that allows bank to make calls to their clients. And what's more important, this particular project, I mean, the call center for us was deployed in a couple of customers in the international area, including a big project in China, which covers the many highly performance system. So a couple of systems to automate some operation processes. The ones that not just some tools, but the ones that cover the process of the whole department. So the whole department performing their job and their duties within our system for the whole their time. So one of an examples is like loan origination system. This one allows to automate the process, which is really complicated and highly regulated. I mean, the process of issuing the credits, the debts, I mean, the loans, sorry. And the process involves plenty of departments all together in this effort. So I think that this is quite serious project that we have been through. So we are not just the team of the beginners, but if we will combine all this project, we can extract similar characteristics for all of them, which will disclose some of our approaches. For example, they are mostly banking system, which in turn means that they mostly deployed in a closed environment. So it means that without internet access. So those systems are not accessible from the internet, but mostly. Another thing is all users are the employers, which means that first of all, they're limited amount and also predictable, so to speak. The next thing is that we have successfully dealt with integration in our project. So we've done it so many times that we've included the integration, the process of learning how to integrate with a couple of services using different protocols and approaches in our onboarding process for newcomers. So this is how we treat the integration. So we are really successful at that. And then the other thing is that we've we've realized that working in small teams for 2 or 3 developers per project, it's very, it is the highest possible, amount of developers before we start to lose the efficiency. So 2 to 3 developers tops is really good for us. And the major thing is the way we are updating our project, because it shows a lot. for example, in order to update any of our project, we notify all users, because we just can't do it, because all of users, we have emails. We have emails of all of users, and partially some of these users we know personally. So we just ask them to log out, and after they did, we stop the application, we update it, we perform some checks initial, and if everything is okay, we start the instance, and everything. And whenever it's not, we just roll back. It happened a couple of times, but not quite often. So this is this approach was really okay for us when we started this project. So these factors for sure can disclose some of our weaknesses, but in general, our combined experience still is, I think, undeniably impressive. So this new project has arrived. The idea is that this was an existing customer who wanted to build some sort of proof of concept or an MVP, for some particular, project, yeah. The requirements were pretty straightforward. So there is a data source somewhere in AWS, which we, at the moment, just thought as some sort of fancy VPS provider, and I'll get back to this later. And there are some users that are external to the infrastructure, meaning that they are just the internet users, from all over the internet. And we needed to provide a web application for them to view the analytical data that is received from this data source. From the technical standpoint, we only needed to avoid loading the database directly. So since at this point we are still stuck to our old thinking paradigm, we are unable to even see that this project is different from what we usually do. And therefore, we ask the same set of questions, which, as we can think, help us to cover all the factors that may affect the design of the future system. And the answers are, in regards of data flow, we have a single data source. Data flow is in one direction, so some system is writing to our data source. We're just retrieving this information and showing this information to the users. No particular, going back and forth. Users are not allowed to do the writing, so they just read the information. Therefore, the data amount. Talking about data amount, there are hundreds of entities, and per each entity we have less than 1,000 operations per day, so not much data, so to say. And in regards to number of users, we've been set. We asked the customer what are we expecting, and they say with a certain level of confidence that actually we will not promote this system yet until it's get completed. So we're not expecting many of users right from the beginning. So maybe a couple of hundred, maybe up to, they said, I just missed, but they said 4,000 at least. Why not 5, but 4,000? Okay. And the only integration is with the master data source. So this is the completely, the easy, pretty straightforward system. So we didn't estimate it really hard. Really for the long period, we have the tight schedule and everything goes okay. So we immediately start to plan this schema. What is the architecture for this project? And this part was not even questionable. So having all these answers on our hands without even questioning, we have drawn the following plan. Sorry. The application server, since we have the application, there has to be the application server. And another one is stateless API server, just to, the purpose of this, just to communicate with the data source. So it receives the REST request and transforms to the database queries accordingly. That's it. We will have our own database to catch the received data, and that's it. So no particular, no any other thoughts came to our mind. So once again, this diagram was not questioned at all, and the only question that appeared at that time is what type of database we could use. So this is the only question that we were focusing on. So according to specifics of the project, we have few writes, all of which are done by us during the retrieving to the data, the data from the data source. I'm talking about the database that we use in our project, our database. By the nature of the project, we are expecting no updates, only writes. So we are those, I mean, this is the analytical data. It just appends, and appends. So not any line of inside and not any row is updated. We just append all, I mean, insert new lines, and that's it. So we analyze this one. At this time during the investigation, we figured out that the data we received from this data source is in raw format, so it's need to be recalculated with them. I mean, with some logic implied. So the final numbers need to be recalculated within the each of entities. So we will definitely require window function, the ones that work within a portion of the data. So this window function need to be supported by this database, I mean, natively. And what we selected is the some sort of analytical database. Within this whole presentation, I will be not dive into specific of the customer details, I mean, the database, because they are not important in the scope of what I'm saying about or talking about. So this database, since we didn't expect much data from the beginning, we apparently understand, I mean, we're actually understanding that according to our experience, over the time, new entities will definitely appear. And the operation number per each of them will grow inevitably. So it means that we will definitely experience maybe not the exponential growth, but at least the geometrical growth, I mean, of the amount of the data being involved. So the things that these databases optimized for the large data, I mean, comes in handy for us. Also, it supports partitioning, I mean, natively, which is also a plus because we are showing the way we show the data is by the periods of time. I mean, for days, for weeks, for months, and so on. So this the day factor, I mean, the timestamp of this data makes a good candidate for partitioning criteria. So we can partition our database according to the dates of data, right? So the window function also were present in large number, which was really easy. And the only problem that this database doesn't provide immediate consistency on updates. So it supports eventual consistency, but since we don't have any updates in our, business logic, we will definitely exclude this factor and just approve this particular database to be in our project. So next thing we usually done is since we were mostly deploying on premises. The challenge was in getting the resources, virtual or physical resources for our applications to be deployed on, getting those resources on time was a real challenge. Since obtaining those resources quite often took as much time as we take for our development processes. So we've been forced to predict the requirements upfront. And we've done it so many times, so we've become really good at it. So without further ado, we just knew how to identify right from the beginning with a certain degree of the confidence what are the CPU or RAM requirements for different types of our application components, how many instances there should be according to some failover approaches, and what is the disk space needed. So we were doing this upfront. So this was just normal for us. After all the developing work is done, we went live, actually. And the thing is that we failed almost immediately. After 1 or 2 agonizing hours of fixing, of managing how to get everything worked, everything worked back, we've successfully handled it. We spent 1 or 2 hours. We have received calls from anyone on the planet, I guess. So this actually didn't cause much trouble for our reputation or the business of the customer, because we was focusing on the correctness of the data, not the performance, because we've been told that those are the things that we will handle later, and we didn't. We just received so many problems right from the beginning, but it's still quite a problem, right? So what exactly happened? The thing that is not a technical thing at all, but this is the problem. So our system was a small part of a giant enterprise application, infrastructure. So little that we know that we are not publishing alone. So we are just, so this data source that we had is not just this random database. So it's a part of another application. And this particular infrastructure, the whole bunch of application was a part of a strategic program. I mean, the strategic program that was executed on the country, I mean, on the level of the whole country. And this particular program, strategic program, was under direct control of the president. So this is what I'm talking about, saying that I was in the blacklist, particularly me, I mean, personally me. And the opening ceremony was broadcast to the whole world. So this led us to have hundreds of thousands of users right at the moment this whole system went live. So we just started receiving requests and the requests. So there were something up to tens of hundreds of thousands of users that we didn't expect it at all. So right after we fixed all the thing, I mean, everything was fixed, and we have come to, I mean, we made everything work fine. I mean, we applied some caching mechanisms and so on and so on. So after we've done all of this, first we just set up a meeting and came to some conclusions that we need to change something. First of all, we can no longer rely on predictive analysis. So the thing that we were good at were no longer applicable for us. And instead of focusing on predictive analysis and make the most reliable prediction and stick everything to that prediction, we can focus on another thing, making our application scalable in order to withstand the whole payload that can be increased dramatically without us being able to do something with it. So making applications scalable was more beneficial for us than making good predictions. So this is what these are the conclusions that we've made so far. So this is where we go to our next segment, shifting to microservices. Up to the moment that we started to shift to this, architecture style, it had been a couple of months since the first deployment. I mean, we were continuously working on the project, and some features and new features have been added, and so on and so on. But at a certain point in time, we have received the thing that we call the grand update. The new requirements appeared, and they were just numerous. So new requirements include the fully functional mobile client. So it means that we need to develop the mobile client for our project, for our infrastructure. So our small MVP kind of project became the platform. There are also a couple of new third-party services that we need to integrate our application with. User profile, since we have a fully functional mobile application, we cannot avoid having the users. So user profiles are being added with all corresponding activities, such as registration, authentication, authorizing, onboarding, and so on and so on. So those are the processes that we will need to include in our infrastructure. The back office functionality for managing all the processes and their parameters. So for now, our project work, blindly. We just monitored the log, and up to this moment, we need to have the module, the functionality for which will allow the customers' employees to do this work for us. And a couple of new features that needs to be added to our project in general. So the first red flag was raised right away. So immediately we've seen that we were using the wrong database. Since we decided at some point of time that we will not be having the updates, this assumption became obsolete right after user profiles and operations have been added to the scope. So we realized that this thing that's called eventual consistency on updates became a really trouble. And the thing is, we couldn't get rid of this database because up to this moment, there's been so much specific queries has been written to this particular database, and the whole logic has been, if we will switch to another database, more traditional one, we will need to rewrite all the queries, most of the logic. So this will be a complete waste of time. So we decided to add another database instead. So we've just introduced new database to our scope, which was a regular SQL database. So we decided those for operational purposes, we will use another database. Okay, and another problem was the more organizational, but apart from having the wrong database, we need to we still had a tight schedule because I mean the customer was the specific of the customer was that all projects need to be done yesterday. So you all familiar with this approach. So despite the work, the amount of work being introduced, we still has a tight schedule. So it means that we need to add more developers to the team. But as we know, the development is one of so-called unscalable problems. Not only adding more developers will not make the work more efficient, but also after a certain point, adding new developer may get even worse. Unless, to be honest, the work is organized in such a way that interactions between sub-teams are at the most minimal level, so to speak, which is unclear how we apply to our project because we are working within one application server, one application. And the next problem is related to the one of conclusions that we've made earlier. The scalability is critical, as we already declared in our project. And one thing is to scale the application server. So this is quite straightforward. We just make it stateless, which we usually do, place all of the application servers under a balancer, and which we also did so many times in our project, and we can do it multiple times. So we can scale the application server as much as we want. But to scale the database is a whole another thing. And for our case, the database should also be scaled somehow, or it become a bottleneck. Because as we experience, we can reach a certain point where we'll get our users number increased, from tens, hundreds of times. So it just may happen. And the problem is with scaling database is that there are a couple of major scenarios how to scale anything, including the database. So the vertical scaling approach and horizontal scaling. Both of these approaches have come with mutually exclusive pros and cons. So one is default tolerant and another is not. One doesn't require making any changes in the way we write code and another does, and so on and so on. So considering all the other problems that we already have, and including this one, we just rejected both of these approaches in our project because they didn't give us a certain level of freedom and confidence in what we built so far. And this was the moment when we realized that the microservices for us were just inevitable. And to be fair, we thought about using the microservices approach so many times, even before this particular project. But every time this thought came up, it was immediately rejected under different excuses. But mostly because, as we understood, employing the microservice approach will definitely give us some unknown challenges that we may not succeed with. And this particular case may change because this was exactly the moment when all of these fears was outweighed by the constraints of the project we're working on right now. Because all approaches and tools have already led us to the failure, right? And most importantly, were inefficient against the challenges we are facing right now. So the main question we had at this moment is how to split the monolith. But because we, including all these requirements, we just have drawn the monolith for us, and we need to split it somehow. And there is no clear, clear, and the single answer for that. So what we did is we decided to stick what we are mostly comfortable with. It means that within our sub-teams, we need to set up the work in such a way that we've done many times before, which will allow us not to invent new procedures and communication plans, not to utilize new organizational frameworks and so on. So we already have a tight schedule. We were unable to learn new things. So actually, we get back into within our memories, we get back to what we've done before. Every day, mostly every project we were developing in the increasingly and rapidly changing area within different another teams working on another parts. When deploying to the bank, you are collaborating with a couple of other teams, the security teams, the managers, the business departments, the analytics, the IT support, and so on and so on. So we are familiar with working in the distributed environment. And we wanted to utilize this approach on ourselves and on our new project. We wanted to reproduce those environment factors for this particular project. And we came up to this concept that we've declared just in our project. First is the business process isolation. You can, in order to understand what business process stands for, you can think of business process as a user story. So the idea is that the business process is a complete thing that has start, has end, has some intention, and so on. So this particular concept says that the whole process should fit into one service. It may be triggered from elsewhere or trigger some other service upon completion, but as long as it is possible, it should remain within one service. The next principle is the data owner. So having only one service being exclusively responsible for some specific entity to be updated, inserted, and so on, or the resource, we could have avoided the problems with inconsistency and like ensuring that all updates were successful or rolled back otherwise, and so on and so on. So this is the whole new challenges for, whole new world of problems that we've never wanted to deal with. So this approach allows us to make the service a single source of truth for this particular entity. So for the entity it owns. So one service can have multiple entities, but in general, we need to understand, we need to have the specific scenario if you need some actual information about some sort of entity, you will definitely know which one to trigger. Okay, and the next thing, which kind of conflicts with the first one, is the shared business function. So the idea is if some particular chunk of logic is required by multiple services, it should be at least considered as a candidate for being excluded as a separate service. So this one may seem a bit unclear, but I will definitely show you a couple of examples in a minute. To be completely honest, we were unable to fulfill all these criteria at 100%, but it certainly helped us a lot in defining the service function. So it was a really good starting point. So let's get to what we've designed. So this was a multiple layer architecture still. So we will have, we had multiple services, and each of which had a single responsibility, and most of them have complied with the principles that we declared earlier. So the first one is group or pair is just frontier services. The one that on the left side is the access control system, the one that is responsible for defining which user is allowed to retrieve, or which operation is allowed for this user, and so on and so on. So this is fully manageable by our customer. The call is from the customer side. So this was. The another part is that all of the APIs, the one that is working with the web clients and the one that is designed to work with mobile application, because the logic for web clients and mobile clients are completely different. So we decided to split this logic, and also the one that works with the socket connections. So all of these APIs were just combined into the one service. The analytical data service, so the one that we've used before with its own database, the one that we already had. And since in our infrastructure there is a couple of services that require clean analytical data provided by this particular service, it's been declared as a shared business function and has been extracted from the application itself. The other thing is back office service, which you are all familiar with, the chatbot service, the notification service. This one is exactly complies with the principle of shared business function, since multiple services may want to send the messages, the emails, the SMS, and so on and so on. So this is completely clearly a shared business function and needs to be made as a separate service. Apart from that, the operation service, so all of the interactions from the users, all of the user intents within this infrastructure were just packed to this particular module. I mean, all of the processes has been within this service, so we just employed our first principle in here. And onboarding service, which were responsible for getting new clients, I mean, new users be onboarded into this infrastructure, because this is a kind of regulated process. And the other part is ML module, which stands for machine learning. So we've employed some features of these techniques as well in our process. So it was responsible for analyzing some videos and images sent by the users. Apart from this group of services, we've had an integration, so-called integration services. So the idea is that integration services were responsible for communicating with the third parties. So all of the integrations, apart from, integrating with the SMS, SMTP, and so on, were just packed. It is just a logical dividing. So the data service, the one that were already been declared as a API service that was working directly with the database. So we still was working with the database, but apart from that, we just added another data source to it, and it was responsible for retrieving the data for both of services, which was good for us because these services shares the same intent, of logic, this data. So it is used only by analytical service, as you can see. The operation, the operation integration module, the one that were integrating with the core operation system. So there has been some sort of core application that were responsible for all transactions and so on. So the idea is that we had a single point of integration with this service, which was called the API. I just renamed it to API number 2 because it doesn't matter what this was. The intention was to have the opportunity to integrate with this server, with this new application. And the last one is just a news retrieving service, which were communicating with the CMS service and retrieves the news and were sharing those news with the infrastructure, with our platform. So this logic, the logic that we have split all our platform to the microservices, to the services, have given us some crucial benefits, such as we actually now could use any database we want in different services. To be honest, we didn't. We actually had 2 types of databases, but still quite a good benefit. The other thing is that we could scale these services individually, which decreased the load to a database. For example, scale the whole application will end up multiple. The database that carries all the load of this whole application need to be has been experienced the high load. But in such case, since we minimize the amount of logic has been done with the database, we can easily scale this application. This application without even wondering how to scale the database. Even if we need to, we just scale the database a little bit. It will still fit. We go to vertical approach. So this was quite good for us. Another thing is just the ability to work in a distributed manner. Each team has a minimal points of interacting with each other and was responsible for a couple of services, to be honest, but the scope of their responsibility was as isolated. And considering that from the customer side, there were different departments responsible for different features or modules or services, so to speak, the development became really isolated, which in turn led to the increase of in development speed for overall project. And we've designed it, we've developed it. It took a while. We've maybe missed some deadlines, but we went live with more or less successful result, which definitely was much more, much better than we had recently. So this took a while for us to utilize all of these benefits and identify the problems that appear, because we understand, we knew we were ready for this. For all of these benefits comes with a price that we need to pay. First of all, the workplace for a developer. So beforehand, we just had the whole project on our local machines. So you have, as being a developer, you just have the whole project. You can test it right away. But now, in order to get the whole project to collect all this puzzle together, to configure it, considering that, for example, there is an ML module and chatbot, which are definitely configured not the usual, in the usual way that we do our Java application, because those are written on the Python. And also our analytical database, which was honestly really complicated to set up initially, and I will get back to this later. So getting all this puzzle together will require to collaborate with all teams. And not only this took time for you, it also steals the time from the whole team. And the time that we didn't have at all at the moment, because we still had tight schedule, and the amount of work was just huge. And on the other hand, just to let you know that dealing with instructions, we actually can provide some instructions, some step-by-step guidelines for configuring our services. This was really not a good idea in the rapidly changing environment. So we've changed things so much faster, so rapidly, so often that we will end up our specification being outdated right away. After one day, for example. So this was impossible for us. Another thing is to maintain the testing environment. So yeah, we have the multiple departments working on different features, which is good for splitting the work. But at the same time, we had multiple testing environments. So each team from the customer side tested its own feature. Before it was published to all other environments, and this, considering the need to maintain the compatibility between the services, was just became a nightmare. So this was really a nightmare. At some moment, we just started to spend almost half of the work just updating the services back and forth for the testing environment. Can you imagine that? And the same goes for the shipping to production, because before that project, even having a single module to update, we just updated one application, we experienced all possible fail scenario, like wrong build or wrong branch being deployed, or wrong version of the application, or unstable branch, and so on and so on. So, for example, we had the problem that while copying the package to the environment, there are some bits that being lost, and we still have the file at the end, but the file has a less size than the initial one. And we knew it right after we deployed it, and we had some errors and need to perform some rollbacks to clean the database. So this was a nightmare, even for one module. And here we have more potential places where an error could occur while deploying the new version to production. So more modules, more services, more things to be deployed, more possible points of failure, considering that if we would do it manually. So again, we needed to resolve some problems. So we have some problems, we need to resolve them, because we don't have the other options. And the first step that we've done towards solving the problem is using the containers. And actually, what we have already scratched the surface for this particular approach, because our analytical database just didn't want to be built for the Red Hat server, which we had at the time. So they were just incompatible in some way. And we read so many documentation that said that everything should be okay and fine, but this particular version of Red Hat was just unsuccessful for us to build the analytical database for. So the solution that actually our system administrator came up with is to deploy this database inside the container, which is running in the Docker, which works perfectly well with the Red Hat operating system. So that way we've not only found the workaround for this particular issue, but also this opens for us the world of containers. And in general, the process was the following. For all our services, a developer that is working on this particular service, the sub-team of developers, he makes all the configuration. he pulls the empty container, empty image, and performs all the configurations with this, based on this empty image. And when developers ensures that on this local container everything works well, after the tests are run, after some analyzing, some manual testing, so on, he just pushes this image to the image repository. I'm just oversimplifying the process just to let you know what the benefits. Sorry. So After this step, all of the developers may just pull the image automatically if they have this particular, the project, this particular service declared as the dependency for their project. They just add a couple lines of code in their project, and each time they need this particular service to be up and running on their local machine, they just start it right away. And besides, all versions for this particular service will be persistent and available at each point of time. And another thing, major upgrade, so to speak, is CI/CD, which stands for continuous integration and continuous delivery, or some may say the continuous deployment. So, and the fact that we've switched to the containers helped us a lot in towards of utilizing those approaches. And to be clear, we already had used the CI part in our company. We even had some procedures. I mean, the CI is intended to automate the development operations process. So we have procedures that were automating the work on some builds being failed after PR is merged. For example, if your changes cause the build to fail, you will be notified right away. And if your build, for example, remain failed for a couple of days, the system will escalate this issue to the project manager, to the CTO and CO respectively. So as you can understand, usually we fix all these issues really fast. Meanwhile, the CD part, which stands for continuous delivery, once again, was new for us. Because, as I said, we've done it annually. And the idea behind it is just how it works. After developers completes all the tasks, all the development on the story or the task, the changes that being pushed to the repository, this is really pretty straightforward, pretty clear, and the PR is created. Right after PR is created, the CI infrastructure, we have some specific solutions, which I said that will not get in depth into the specific parts, but CI starts the pipeline, which were configured in such a way to handle this the particular event. And apart from trying to build, run some tests, it may contain some style checks, some compliance check, and so on and so on. So those checks can be configured as you wish. So the result of this particular process, this bar, is a container image, which were all of the code, which contains all of the code, all the dependencies that has been checked, that has been built, compiled, and so on and so on. So the image that is ready to be deployed, to be shipped to production or whatever, to the testing environment, it doesn't matter. So this CI uploads then this image to the image repository, which is already a part of the continuous delivery. So the continuous delivery starts here. And what's more important is that CI triggers the orchestrator, so-called. So the orchestrator is the thing that configured to know what image goes to what service. So all of our infrastructure was already configured in this particular, for example, like here we use the Elastic Container Service. So all of the service has been declared, and with all the requirements for the instances, they are being shipped to network configurations and so on. So this particular thing just contained the configuration for all our infrastructure. And after being triggered, all it does is just upload, this pull the image from the image container registry. And sorry, I just missed the slide. And it adds a new empty instance to the or the pod. It depends on the configuration, but the idea is just it starts a new instance and deploys the image to this instance. And when the instance is up and running and successfully respond to the health checks, the old instance is being terminated immediately after it is done. After the first is already. And if it's done, if the stopping the application is done, it's just removed from the service. And if we had a couple of instances needed to be like for example, for access control system or for back office, we can it just complies with the setup policy how to deal with that. For example, it can not stop one instance, but rather open and raise two other instances, and when they will be ready, it will shut down the previous one. So the policy is really configurable, and Really powerful tool. So the key feature for this process is that all of this is executed automatically. And different pipelines, for which were for our project, was triggered for different environments. I mean, it may be working as a branch, targeted to the branch or other attributes. I'm just not aware of it because it has been configured once and we never touched it again. So the idea that all of these things appeared and it has been executed automatically. This is the key feature. So after this all being done and configured and brought to working condition, we've made some conclusions again. So we've reanalyzed what we've done so far. So first of all, why we even never thought of using CI/CD in our previous projects? And actually, this makes sense because why to struggle, why to suffer of being deploying manually when we can use such simple tools in order to do that. And even for not cloud applications, for on-premises, there are also some solutions for orchestrating those approaches, those processes. And the answer to this question is that we just had a choice. Right before this project, we just could avoid it. Because dealing with new configurations, learning new stuff we just not have time for that. But on this particular project, we have no other option than we just being forced to utilize these approaches. And the second one, is there actually anything more to optimize? So we've deployed all those things. We've realized what is the benefits of it. What is the time that has been already free for us in order to focus us on the development process, and many things, maybe there anything to optimize as well. To do further, and this is when we are going to the final part of today's presentation, the chapter that is called Cloud Native. This is the main idea. This quote just depicts the main idea that we have focused on within this particular effort. So let's break into small pieces all of the choices that we've made so far, starting from the file storage. In our project, we store files within an onboarding process. In our previous project, we actually have done it so many times. I said that we're working with the files, and not every time we use the. Considering the fact that there are not much files appeared in this particular case, we used our solution that was based on the. It was our own development. It was fully customizable, which was really good for us. And to be fair, it just worked over a specifically tweaked database. So this means, at the same time, this approach required us to monitor its state, because as we are responsible for these particular solutions to be working well, and all our services are crucial. So it means that we need to monitor, and this also steals time. And what's more crucial, it has a predefined capacity. It means that we need to understand what is the required capacity up front once again, and we decided that predictive analysis doesn't work for us anymore. And I will provide some examples a bit later. So this means that will be a time in the future when we will need to move it to the larger disk space. Shut down again and maintain all of the operations. Just understanding that we need to bear in mind this particular effort to be done in the future. We're just crucial for us. Besides, we need to do it manually, for sure, because it's our solution. But if instead of our own solution, we will switch to S3 service, for example, we would receive the following advantages. First of all is unlimited capacity, which just which allow us to forget the things to scale it up front. Forget to doing it, forget to managing it, to keep bearing it in mind. So this particular service has an literally unlimited capacity, and the possibility to categorize stored files using tags, which is more than enough for us, because the only thing we require to customize is just add some attributes, some key value attributes to our files that we store in order to be able to, to extract some metadata that we require according to the business logic. We also could set up a policy for moving old files to other storage options to reduce the price for our customer, because we actually, the reason we need need to store these files is we just store it for legal reasons, which makes it acceptable if, for example, those files will be retrieved with not immediately but within hours on demand. So, but in such case, the customer will pay the less money for that. So this is a completely good option. And also, while set up, once this policy was set up, it was working automatically. And what's more important, it was serverless, which means that all the risk was delegated to the AWS. And definitely it could handle that. Another thing we need to analyze is the way we actually scale our services. So we said that the scaling is the crucial for us, and we need to do it in a proper way. For example, when we do it manually upfront. How it's done? So we need to focus on this thing. So we need to monitor the load and actually predict the load. Once again, we're trying to predict something. For example, once we saw as being involved into mailing list, we saw that email from the marketing team that they are going to place the advertising materials for all bus stops. The most popular bus stops for all major cities in the country. So this was a huge marketing campaign, and we understood that it's good for that we have noticed this thing, because we are not directly being involved with working with the marketing department. We just saw the email, and this made us understand that probably we should scale some services upfront. So this, once again, we will add the new instances manually once again, which is not good for us. So instead of this, we could use the auto-scalable groups, which work perfectly with our orchestrator, with the services that we already use. The idea is to configure the metrics in the CloudWatch so that if a certain condition, which was decided and declared by us, which this particular condition is met, we will scale out. And if, for example, another condition is met, we will scale in after a certain period of time. For example, there are some rules and some processes being involved in this particular case, but this is doable. So no participation from our side is required. It means that we are not monitoring this thing at all. It's just being done automatically for us as a developer that were responsible for many environments, for many applications in production, so many nights without sleep, and so on and so on. So this was things that may be done. On the other hand, and I will just speed up a little bit, we have another service that is rarely used and rather requires scaling down. It's a machine learning module. It doesn't hold a state in any sense, and it means that it can be easily turned off and back on when needed without losing any data. So in such scenarios that we've discovered that AWS Lambda will make a good candidate to handle such cases. And the idea is of using Lambda is that the code is executed only when Lambda is triggered. So not any service being idle for any time. It just starts when needed, runs its code, and just being disappeared. That's all for us. And all of the time it just doesn't exist. And with adding another of the AWS service, which is SQS, which stands for Simple Queuing Service or something like that, to the scope, will allow us to automate this process as well. We only need to fire the event to this particular service and to be sure that everything will be processed as well. So, and this is also can be scalable. So we can identify, we can define how many lambdas may be involved in the process. And this particular scenario, actually, just to make long story short, we've took a closer look to this particular service and the properties that it's provide for us, and decided that we can reach the dream of the any microservice developer, the decoupling service approach. approach. So the idea is, just to explain it a bit faster because we are running out of time, so that we have a module that integrates with a third-party system, which we are not in control of in any sense. So there are a couple of scenarios when they asked us to stop the request from being sent to this particular service, for example, for maintenance. And the problem was that either we need to store all these requests and handle the retry request and dealing with all of this, the whole new world of new problems with transactions being required, replayed, and so on. Instead of this, we can do either this, or we could try to pause the request from other service, which will just delegate the problem back then. And apart from that, we need to know that we have a couple of services that may be interacting with this particular one, which makes these all procedures. For this event occurred so rarely. It happened just once in a couple of months. Having the whole infrastructure in place just to support this particular event, which will take a couple of minutes, it's a lot of effort. It's too much for the effort. And the thing that if we will use this SQS service, which provides the guaranteed delivery, unlimited throughput, and so many qualities, we can end up just our services having trigger the events. They will just firing the events to this particular service. And when the second application, the API, up and running, all the requests will be processed right away. But if it's down and up again, all these requests won't be lost, and they just will be continue to be processed until they will get the response of being processed. And dealing with backwards, with the responses, we've ended up with introducing for ourselves another service, which is SNS, Simple Notification Service, which can, the key idea is to distribute all the receiving back message to all those services that has been subscribed for those particular messages. And using SQS again might ensure that this particular message will be processed on those services as well. So having this on hand, we decided that what if we will go further and we can reach the thing that we've decided to call the complete service independence, which means that there's the thing that a bunch of topics has been declared, each of which represents one particular entity or event type, right? So every service can push the notification, the events that he is responsible for this topic, and all the services that previously have been subscribed for this particular topic will receive the messages through the SQS that will ensure that everything works fine, that all the messages has been processed, and this can happen in multiple ways, and this will give us the thing that, for example, if new at a certain point of time, new service will be introduced in our infrastructure, and we know that it requires some particular event to be sent here. We just made the configuration that this particular queue, SQS service made for this particular application is subscribed for this particular topic, and that's it. So we will actually, this will open for us a new set of problems that we will have to deal with, and so on and so on. But the general problem that it never happened. We actually never had the opportunity to employ this particular, these approaches in our application, and there are the reason. And the reasons why we didn't is the most valuable thing today that I would like to share with you, because this is crucial. So first of all of these changes that I've described in the couple of slides before doesn't bring too much, much business value to the infrastructure. And the thing is that in the way we do things, the business is the one who decide what will be done and what will not. So these particular changes, being done separately doesn't provide much business value. The next thing is most of these innovations solve only one problem. Most of them solve, we can say that there are a couple of problems that they're solving, but in general, this just minimizing the risk that we carry. But the problem is most of this risk is under our responsibility. So it's no problem for the client, for the customer to deal with, because all the guarantees are provided by our company. And the latest one, and this is the thing that is really unclear, but it has to be said out loud, that we just lost the sense of urgency, because as we began our project, we will be all together with the customer in this particular idea to launch this project, whatever, I mean, wherever it takes. It has to be done properly, but the focus has shifted from the being, I mean, innovative, being made some dramatic decisions, some strange decisions, and now it's just making everything works. And we ended up with some changes that being lost because of this reason mainly. And this fact leads us to the final sets of conclusions that we've came up to. So first of all, automation could save us so much time. As the developers, we help other businesses to get rid of routine stuff and focus on what is really important and what is really matters. And doing the same for ourselves, I mean, automating the things that avoid routines, works that can be avoided for ourselves is just a matter of common sense. I mean, it's just smart thing that needs to be done. Another thing is managed services save much precious time for developers as well. So we are just delegating all the risk, all the work to the AWS. And sure, the budgeting needs to be taken under a thorough consideration with this movement, but still resources are resources. I mean, maybe they will overpay for the services, but we are also the resource that being paid, I mean, valuable in any sense. And decoupling allows building, the decoupling approach allows building really resilient infrastructures, the ones that are much easier to support and develop and to adapt to new changes and so on. So decoupling is the key characteristics of the microservice to be assessed and on. And the most important one, everything has a proper time to be done. The general thing that we need all to understand. So if we say, for example, if we, at some point of time we will say that, okay, we just need to focus on this one and we will solve problems upon the receiving, this is not the case, because we will actually have another problems and so on, and it's a sense of urgency and sense of timing will be lost. And we not always are able to do this in time, but we still, we need just at least we need just try. Because it might happen that at a certain point of time, the fear of being, of things being broken will overcome the benefits that this particular effort can bring. And so many great things are not done, not only in our project, but in general, just because they have not been initiated at the right time. So, and just to set up the sense of hope, all of these ideas were declared as a technical debt, so to speak. So at some of them have already been taken into development, and some of them being done, but many things are still pending their approval, and you probably understand what they are. So at the end of the day, all of what we've been through was a hell of a journey, so to say. But no one from us, from our team, regrets anything that we've done. So there are a couple of regrets that we've came up to, but in general, we're glad to have such an experience. We're glad that it made us just break out our shell and go out to the new world of new paradigms that need to be utilized, need to be applied, need to be employed, and so on and so on. So this journey just completes with us. Ended up other people that other than we've been right at the beginning. So that's pretty much it from my side. If you have other questions, I will give the word to my colleague, and we will deal with the Q&A session. Are you there?
Yes, I'm here. Thank you so much. We have some time left for a few questions, so maybe we'll start from the top, because we collected all the questions in the chat. This is one. How complicated is the cloud migration process? What was the hardest part for you in your experience?
Yeah, apart from what I just explained, the thing is that the technologies are not the problem. So you can become the solution architect. The person who is well known of all of the services that has been provided by the cloud providers. In a short period of time. But the key idea is to make a mindset transition. because you need to step out a little bit and try to change the way you view the questions, to view the problems, right? So this was the hard problem. Because, for example, have you had some sort of experience in your team, and you already know what each team member will say, and so on and so on. So you as a team ended up with some sort of solid state, and this particular effort will break this solid state, and maybe new conflicts will be arising out of the ways that other people. One is saying that this will be good for us. SMS is not a good idea, SQS, and so on and so on. So there might be you will get down to the most initial level of getting things, because there will be no history of your company of some things being employed. So definitely this is, the operational part, the intercommunication part is most difficult thing that to overcome during this job. I hope this answers your question.
Thank you so much. Another question from one of our viewers, and this is the question when you can turn into a profit of some sort. How do you see the future when it comes to the growth and development of clouds? Any plans?
So how do you see the future when it comes to the cloud growth development? Any plans? To be honest, the project and the team that I was talking about is not the one that I'm already participating in. And definitely not the developers are ones who decide to shift to the cloud, but definitely, 100% sure that moving to the cloud will allow to utilize some benefits that you were unaware of, before. So it's like getting, for example, can you imagine getting into the country when you can not breathe? When you can survive without breathing, and you will only then understand how much effort it takes only to breathe. And right, because you do it all the time, you don't understand how much effort it takes right away. Okay, so this is abstract example, but the idea is moving towards the microservices will allow us to utilize, at least to handle much more effortless the spikes of the load and so on and so on. So there are plenty of technical issues that you will face with, and the cloud solutions will help you with those problems very good. Otherwise, you will just reinvent the bicycle. Right.
Great. Thank you so much. And another question about Luxoft from one of our viewers who joined us a little bit further on. What are Luxoft's ways of supporting the team when it comes to cloud migration?
It actually depends. From the technical standpoint, there are plenty, plethora of the knowledge materials, sessions. There are plenty of the the instruction, the courses, and so on and so on. So from this standpoint, from the knowledge standpoint, you are fully packed whenever you are working at Luxoft. And speaking about your project being transitioned to the cloud, it really depends on the business you are involved in. So as I like to say every time when dealing with the customers and with the executives, everyone can rule a company. Everyone can make a critical decisions. It depends only whether you can deliver them, when you can provide the rationale in the perfect way, and so on and so on. So actually, I would say that it doesn't matter, Luxoft or whatever company you're working in, whether it supports or not. It's you who decide whether you need to do it or not. Actually, to be honest, it's not. It's not 100% your decision, but you decide whether you will shift to them or not. You need to. You need to learn the things that how it will be beneficial. And my advice, I hope that you have extracted from this presentation, is to employ the business benefits onto your decision. And if you will talk about transition into cloud services from the business standpoint, from the benefit standpoint, you will succeed in any company. But at Luxoft, we are fully packed with the technologies, with we have the access to the environment, we can test our theories and so on, so proof of concept and so on. So from the Luxoft standpoint, we're fully packed with the design.
Okay, I think this answers the question fully. Thank you so much for being here with us and sharing your knowledge, sharing your experience. I think this was a very, very great, more than an hour for our viewers. To all of you guys who stayed with us, who listened to this presentation, thank you so much. We hope it's not the last time we are seeing each other, and we will let you know about possible next events. So Yelan, thank you so much again for being
Thank
here with
you.
us.
Thank you
Thank
for
you.
having me. It's been a
Thank you
pleasure.
so much. And I have another information for you guys. As I can see, we have our competition results. So those wireless earphones, sorry, we have a winner. It's Sławomir S, and he has a Gmail account. So please let us know that you are here with us because you are the winner of the earphones. And as the power bank goes, Roxana M, she also has a Gmail account. So we'll try to contact you as soon as possible. Congratulations. You guys are the winners of our prizes. Guys, thank you so much for being here with us, joining us. So once again, please find our social media outlets. Find us on YouTube and find us on Facebook. Give us a like, and we hope to see you guys soon. And right now, have a great night. Goodbye.
Goodbye, guys.